Good afternoon, everyone. My name is Swapnil. I'm co-founder and CEO of Uravu Labs. The year is 2016, and me and one of my other co-founders, we are at NIT Calicut campus. And it's a campus which is almost 25 kilometers from the city and gets water supply from a nearby river. So there was a dry spell, and in February 2016, campus runs out of water. And being almost 4,000 people in the campus, including students, staff, and all faculty, there was no good water supply. So what the authorities started doing was calling water tankers and giving us water, which we had to go and collect. And we were just rationed 1 or 2 buckets per day. So that was the reality we lived with for a couple of weeks. But worldwide, that's a reality almost 2 billion people face for many months of the year. And that really got us started to think about, what exactly is the water infrastructure which exists today, and what can we do better going forward. So the idea at Uravu is we want to reimagine water infrastructure for this century and probably beyond, and look for alternative sources of water which take us away from depleting our groundwater sources. So India as a country, almost 85% of our drinking water needs today come from groundwater. And then if you even have a centralized water infrastructure like you see in cities, it stops providing water once you go into outer fringes where this infrastructure doesn't really exist. Even in places like Bangalore, if you go to North Bangalore, Sarjapur, and many other areas, it's all either groundwater or you will have these water tankers coming and giving you water. So the idea at Uravu is simple. We take moisture from air and using a desiccant-based technology, which is basically a material to absorb moisture, and then convert it to drinking water, high-quality water using renewable energy sources. We produce really high-quality water anywhere and everywhere you want. And the idea itself becomes a sustainable and inexhaustible solution, because air contains almost 6 times the water we have in all the world's rivers combined. And the good part is, because of the Earth's natural cycle, it all replenishes in just 8 to 10 days. To give you some context, groundwater takes almost 1,400 years to replenish naturally. So the stark difference between 8 to 10 days versus 1,400 years really means that air could be used as an infinite source of fresh water. And the idea that you don't have groundwater or don't use a technology like reverse osmosis, which also wastes a lot of water, we are able to offer a very sustainable, grill-free solution for customers who use this to overcome a lot of their challenges face when it comes to fresh water, plus also go toward a more sustainable solution overall. So this is the setup we have in Bangalore, Hennu today. We have already scaled our solution to 3,000 liters per day. It's a 15,000 square feet warehouse where the idea is that it's a modular technology, and going forward, we'll be scaling it to another 10,000 liters per day by March. And today we are working with mostly hospitality customers like Leela Hotel, Royal Orchid, Hyatt, and a few partner restaurants, and some beverage companies as well, with which we are going to launch products very soon. So it's built as a modular technology with 500 liter per day units, and it will be scaled to much larger volumes going forward. And the good part is it's a heat-driven technology, and it's fully flexible with many kinds of renewable energy sources. So we can use solar heat, solar PV, even waste heat from industries, or even biomass waste for that matter. So any heat below 70 degrees Celsius could be used, and it becomes like a much more flexible, renewable solution at lower cost compared to existing options where you have air conditioning technology where you're basically cooling the air and condensing the water. So just a glimpse of how the whole thing works. So we basically have this liquid solution which is interacting with ambient air. And it absorbs moisture from the air as it keeps on interacting and gains weight. And then once that solution has gained weight, we pass it to another chamber called as a desorber, where we heat up this solution to about 70-75 degrees Celsius. And this packing section just helps us provide the surface area where the interaction could happen and moisture could release further. So moisture gets released, which was earlier absorbed. It's almost like a distillation process, and then we collect it to form very high quality water. Now air doesn't naturally contain any minerals, but we can, because we collect almost demineralized distilled water, we can formulate it with any kinds of minerals formulation. So today we are targeting mostly the hospitality market with the packaged water, but also supplying bulk water to a lot of our customers from our facility. So this is the main motto we go ahead with. How do you save water by drinking it from air? We have already saved more than 3 lakh liters of groundwater. We just started our commercial operations in April this year. Last year we were at 20 liters per day, but within just 11 months we have scaled it to 3,000 liters per day. We have also prevented more than 2 lakh single-use plastic bottles to go into the environment. And we also have a reverse logistics model. So a lot of this packaging gets reused multiple times. One of our packaging glass bottles we have reused almost 60 times. So that means you have a localized model where you're producing water very close to your customer base and then also transporting it in just very 5 to 30 kilometer radius instead of transporting water over thousands of kilometers. So that's the whole idea. I think one slide was missing. But the idea is that we'll be moving to other categories. So hospitality is one sector we are aiming for today, but the idea is that as we scale and expand and also reduce our cost, there are a variety of applications we are looking at. So beverage industry is one such application where we are already done pilots with AB InBev, Diageo, Radhiko Khaitan for supplying very high quality demineralized water for their products. Second, we are also looking at pharmaceutical applications where you require very high quality water for your lab grade applications or your water for injections and similar aspects. But the broader idea and vision has always been that how do you make this new kind of infrastructure where going forward you can provide very high quality drinking water for a lot of urban and rural areas and even remote areas where water access is a big problem. So we're using science, technology, as well as building a commercial model where as the technology develops and scales, we're also able to build a strong business and use case going forward. Yeah, thank you so much.